Let me tell you an interesting fact. Let's say that your friend wants to play a prank on you and he has given you the following challenge. He has asked you on a very hot summer afternoon to walk barefooted on a concrete road. Now you will find that the moment you start walking barefooted on a concrete road, you are barely able to take 2 or 3 steps, and your friend has actually succeeded in his prank. Now, do you know why he asked you to walk on a concrete road and not on a wooden surface? If on the same hot summer afternoon, instead of walking on a concrete road, you walk on a wooden surface, you will find that you are able to easily walk through. You are not able to feel the heat as you did in case of the concrete road. So now, why do you think this is the case? Why do you think that the concrete road is getting heated to a higher temperature, but wood is not getting heated to as high a temperature as the concrete road? Well, let us answer this question. Now, before I answer this question, we are going to take another similar example. Consider that it's your holiday and you have gone to the seaside for a vacation. Now, once you're on the beach, you will notice that when you're walking on the sand in the afternoon or even in the morning, you are able to feel a significant amount of heat that is coming out from the sand. And that is why if you walk barefooted on the sand, your feet hurt. But the moment you get yourself into water, you will find that you are no longer able to feel the heat. The water feels much cooler than sand did. Again, why do you think this is happening? Why do you think that sand is getting heated to a higher temperature than is water? We are going to answer all these questions with the help of a scientific concept. That scientific concept is known as the heat capacity. Now, the heat capacity of a body is defined as follows. Heat capacity of a body is the quantity of heat required to raise the temperature of a body through 1 degree Celsius or 1 Kelvin. So now, if you have to answer the question that why it was more uncomfortable to walk on a concrete road or why it was more uncomfortable on the sand than in water, how can we do so? First, let us find out how we are mathematically defining heat capacity. So mathematically, heat capacity is defined as the ratio in between the amount of heat absorbed or released to the difference in temperature caused. So if amount of heat is being absorbed, it means that there is a rise in temperature. In other words, we can say that when heat energy is being absorbed, the temperature is increasing. Likewise, if there is a release in heat energy, it implies that temperature is decreasing. Now the unit for heat is joules and the unit for temperature is Kelvin. So we can say that the unit of heat capacity is joule per Kelvin given as J per K. And this heat capacity represented by C is fixed for a particular body. So now let us answer the previous questions that have been bothering us. Firstly, I am going to answer the question of water and sand and why it is so that when you are walking on a sea beach, you are more uncomfortable on sand than on water. Now, water and sand in this case are under the sun, which means we can say that they absorb the same amount of heat energy from the sun because they are receiving the same amount of heat energy. So Q in this case remains constant. Now you felt more uncomfortable walking on sand than in water. Why is it so? Because if Q remains constant, then an increase in delta T means that the heat capacity is less, and a decrease in delta T means that the heat capacity is more. Why is it so? Q remaining constant, we find that delta T is in the denominator. So if we have a high value of delta T, it means that heat capacity is less. Likewise, if we have a low value of delta T, it means the heat capacity is more. So when you are walking on sand, you feel more uncomfortable. Why? Because the rise in temperature has been significant. It has been much more than that of water. So this implies that since the rise in temperature of sand has been more, the heat capacity of sand is less. Similarly, since the rise in temperature of water has been less, the heat capacity of water is more. A similar thing happened in the case of wood and concrete. When you walked on wood, you did not feel uncomfortable, but the moment you stepped on concrete, you found that you could barely walk. The same is the reason. Because the rise in temperature of concrete is more, its heat capacity is less. Similarly, since the rise in temperature for wood is less, its heat capacity is more. Now, what do you think will happen if in place of Q remaining constant, we have delta T remaining constant or the change in temperature remaining constant? In that case, if we increase the amount of heat, that is, if we increase the numerator, it will imply an increase in the heat capacity. Likewise, if we decrease the numerator, that is the amount of heat, it will imply a decrease in the heat capacity. So we can say that more amount of heat energy absorbed for a given rise in temperature implies a greater heat capacity, and for the same rise in temperature, if we have a lesser amount of heat energy absorbed, it means the heat capacity is less. Now we find that heat capacity is a quantity which does not have mass in it. Or in other words, if we are to consider different bodies having different mass, their heat capacities will be different. Now, even if we are to consider a same body, that is, let's say water, of different masses, then each mass will have a different heat capacity. So there was a need for the scientists to come up with a quantity that is independent of mass. So this is the reason why specific heat capacity, a new quantity, was brought into play. So what is the specific heat capacity of a substance? It is the amount of heat energy that is required to raise the temperature of unit mass of the substance through 1 degree Celsius or 1 Kelvin. Notice that there has been a slight difference in definition as compared to heat capacity. Over here, the term unit mass has been added. So how can we define specific heat capacity scientifically? It can be defined as Q, that is the amount of heat energy absorbed or released, divided by the mass of that body times the difference in temperature. So as you can see, a new factor, that is the mass, has been incorporated. So the incorporation of this factor makes this quantity, that is the specific heat capacity, independent of mass. So what is the unit of specific heat capacity? The unit of specific heat capacity will be joules per kilogram per degree Celsius or per degree per Kelvin, because the SI unit of temperature is Kelvin, the SI unit of mass is kilogram, and the SI unit of energy is joules. The SI unit of specific heat capacity is joule per Kelvin per kilogram or joule per kilogram per Kelvin. So this is the formula, Q equals mc delta T. Now if we have been given the specific heat capacity of a substance, we can easily measure the change in temperature when we apply a certain amount of heat energy to the body. And the mass of the substance can be easily calculated. So knowing all these three terms, we can easily calculate the amount of heat energy that has been supplied to the body or the amount of heat energy that has been radiated by the body if the body is heated or cooled respectively. So here we find out the basic differences between heat capacity and specific heat capacity. Heat capacity depends on the mass of the body, that is, more the mass, more will be the heat capacity. And specific heat capacity does not depend on the mass of the body. It is independent of the mass of the body. If we consider a kilogram of water and if we consider 500 gram of water, they will have different heat capacity. But the specific heat capacity will be the same because it is being considered for unit mass. The unit of heat capacity is joule per Kelvin, and the unit of specific heat capacity is joule per kilogram per Kelvin.